Hi, my name is Amrit. We've heard that IIT Madras is the best place to build. So we've come down to the Sudan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IIT Madras the best place to build.
We're not really trying to get rid of carbon. It's expected that in the next 15 years, given the acceleration of AI in common usage, this number will get to about 14%. If it gets to 14%, this will immediately start becoming one of the top two sectors of GHG contribution.
Scary to even think about it. Hi, I am with Dr. Satya Seshadri. We are sitting in CFI and we are discussing, we have a lot to discuss on our plate today. Maybe Professor, of course, firstly, welcome.
Thank you.
And maybe what we can do is, since we are sitting in Nirmaan and CFI, we can talk about this first. From when I was in campus, we didn't have CFI or Nirmaan. And then there was CFI and now there's Nirmaan. And now it feels like there's an entire innovation stack. So can you lead us through and explain to us what this is?
Sure. As you rightly said, CFI was created in 2007, thereabouts, to become a student tinkering lab, just more of a makerspace, an after-class program for students to come and explore building. The whole thing about what they can achieve with their hands. And I think that gradually led to there in about 2013-14 timeframe, a couple of these students wanting to create enterprises out of it, which is a natural progression. So Nirmaan was created as a club within CFI, just like there are how many other clubs. There's a product design club, there is a genomics club or a AI club. So many clubs are created based on special interest groups of students. Nirmaan was created as a pre-incubator. So what it really meant was to provide some kind of a platform for students to learn how to create startups, and in the process, how to approach market, how to talk to customers and so on, and created this with certain set of mentorship. Like for the product design and others, there is mentorship available within campus, the technical mentors, the faculty advisors and so on. For this case, we had to go outside to bring in alumni who have created companies or led large corporate positions to come back and support these students. And that's how Nirmaan was created. And what we recognized
Hold on 1 second. So CFI is a student maker space and there are clubs in CFI.
Yeah.
And these clubs, how are these clubs organized?
Clubs, typically you put it together or students come together and create a club with, I would say, a special interest group. So for example, if a series of students are interested in product design, there is a product design club that comes in and they create a charter, they create a set of projects they want to do with the goal of realizing something. And then they come and seek some funding from the CFI student administrative body and the faculty advisor to say, can I realize some of these projects? It can come and go depending on the interest of students. Right now, for example, sustainability, campus sustainability is being created as a club. There's a lot of special interest groups that are being formed, primarily because now sustainability is a buzzword or a keyword, a happening thing, and people are trying to understand how innovation can happen in those spaces.
Yeah. That's interesting. I know that Raftar was a club or is a club.
Raftar, so some of these clubs mature to become competition teams. Essentially, it gives them a goal post every year to achieve and target. So galvanize people. Clubs are more, I would say, a bit lower or lesser rigorous in terms of how they do the engineering. It's more like a tinkering, proper tinkering. But when it gets to these competition teams, engineering becomes more important. They work almost like a corporate R&D. They have stringent engineering goals because when they go to these competitions, they participate in a lot of design validation. It gets that professionalism into the team, and they go through a rigorous process of simulations, certifications, testing, and so on. That gets them the engineering mindset, which helps. I think that's one of the reasons why this space is a very nice maker builder space, is because it's a progression from simple tinkering to actually building products.
Yeah, and these are international competitions like the Hyperloop competition or the Formula student racing competition. And also, like you were saying earlier, that at some point students started maturing with their work here to start thinking about enterprise. And I remember that Swapnil Jain, who's the CTO at Aether, was in the Raftar Club.
Yeah.
Or I think he was heading the Raftar Club.
He was, I think, one part of it. Yeah.
And then Vignesh, who was the CTO at Hyperverge, was in the AI Club.
AI Club. Yeah.
At CFI. So that I can see that transition happening. So then Nirmaan was a club first and then became like a full-fledged entity.
Full-fledged enterprise or entity, as I would say. It's because we found that there are certain set of students who will do it anyway. There are a certain set of students who are on the fence who could potentially look for opportunities to learn more before they commit.
Right.
So that's where Nirmaan comes in, where he said, you get a 1 year or a 2 year kind of a runway where you can try your enterprise, almost do it in a risk-free manner. So you get some kind of a seed funding, you get all the mentorship, behave as if you have created a company, learn everything that is there. And if you want to go even beyond your graduation year and still continue to be affiliated with the center, we also allowed them to defer the placements so that they can really make sure that what they're doing is something they want to do and not get into it and then struggle later. So that's how Nirmaan was created. And I think, slowly started getting more and more people. And of course, this nice integrated building wasn't there. So we had the CFI, this was the old workshop, as you probably recall, that CFI had. And for Nirmaan, we need we needed a pre-incubation space. So I got then Dean Shiva to give me the abandoned kitchen of Kaveri Hostel. So we converted that kitchen space into a co-working space. So that's the first place where Nirmaan was there. Yeah. And we used to call it as the kitchen that cooks startups.
That's damn good.
Yeah. So now I think with this space, we've matured quite a bit. Now you can see a progression, right? You have a tinkering lab. You go to the first floor, you have Nirmaan space, and then you go to the second floor where it's more of a training center. But now there is more cooking in the second floor, which probably will be announced soon in the form of IITM Global, where we're looking to expose our startups globally as well. Take IITM startups to say, how can you compete across geographies? And that's IITM Global. So it's a nice progression to an idea to a global dominance. I mean, it's a nice big word, but yeah.
But it's interesting. It's a startup journey in itself, right? In the sense that CFI started where the old foundry workshop was, and maybe foundry had to be removed, and then CFI came in. And you are saying that Nirmaan started where there was an old kitchen in Kaveri Hostel, and from there it's moved to this sort of integrated space.
Yeah.
And how does it move forward? I remember you also telling me that there's a parallel journey of this a degree in entrepreneurship.
Yeah. So that's an interesting aside where probably many of us did not know or do not know that IIT Madras had the oldest degree in entrepreneurship in India. It was in 1983 that the MS in entrepreneurship was created. So by far the oldest, even when entrepreneurship probably was not even a big word. So this degree was created. The intention was for people to come into this ecosystem with some idea and then navigate their way around and find mentors, find technical experts and create a venture. So that was more of a selection in process. So it produced a few entrepreneurs. ZB is one example, which is a startup or which is now a company in Research Park. And there are a few other examples. But then what we realized is there could also be an alternative where with the awareness of startups also being built among faculty. But then faculty also had this challenge of not the person who wants to convert it. So we flipped the model to say, okay, you don't need to come up with an idea. There are enough and more ideas in the labs that are waiting to be commercialized. They have done the science de-risking. They need the technology de-risking and the product market fit. So can we identify students who come in and marry the faculty for like in a figurative sense to work with them very closely over a 2-year period and discover the market opportunity where technology translation can happen. This was also, I would say, triggered by the fact that the GDC program has been operating for quite some time and the intention was lab to market. But when you take an existing faculty along with this existing set of students and try to push them to the market, there are very few who take the journey. Rest of them, it is too traumatic, to put it lightly. It's not their cup of tea.
Yeah. Startup life is
It-
I remember one description being it feels like getting your arm fractured every day.
Certainly. And you also have this, I mean, typically there's a faculty guilt. You also have this guilt saying, I'm in an academic setting. I need to be advancing academics and research. What am I doing trying to
Commercialized.
commercialize? And once it goes past typically a technology validation stage, it feels like I'm not adding any more value to it. So that's where a lot of failures happen. There are a few people who are able to navigate primarily because they had found a great grad student or somebody had come their way who could take it forward.
Mm.
But it's by accident and not by design.
Yeah.
So that's where we redeveloped the MS in entrepreneurship program this way to identify more such people to come in. The systems still are heavily dependent, academic systems still are heavily dependent on how much do you publish, how much students you graduate. And those are metrics, those are chips on the shoulder for an academic.
Sure, because there's a best teacher award and there's a
The best researcher award. Then you based on your publications, your H index or your I index, you get called to national committees. You become on selection panels and all. So that's kind of a progression that an academic experts.
sure. And I
Yeah,
also see that you are the Shell chair, so that must be also something that comes through an academic route.
Shell chair primarily it comes through an academic route. For me, it's interesting because it came through our extensive engagement with the industry by creating the Energy Consortium.
Okay.
So, Energy Consortium, as we conceptualized it, we said there are more than 50 plus academics in the institute who's working on something or the other in the domain of energy. All working on different areas, which is relevant to the whole energy transition debate that we are currently having and action that's happening. But all of them are working at a level at which it stops at some level of publications and patents and so on. Now, how do we progress it? So, the consortium was conceptualized as a industry, academia, government platform where we could bring in all stakeholders who is relevant to this transition and then kind of come up with broad areas in which we should focus on and not fundamental research alone, but also translational research. And in that, I worked extensively with Shell, and Shell felt there is a lot of areas that they could work. Being a very large company, which is pretty much focused on every domain in the energy space, directly or indirectly, they felt this is an ecosystem that they would like to tap. And also being, they have about 6 or 7 global academic partners, and there was nothing in this region. So IIT Madras became one of the global academic partners for Shell. So they strengthened that by becoming a member of the consortium and also parallelly having a bilateral set of projects with individual faculty members who could then contribute to working along with Shell researchers, because Shell has a technology center in Bangalore on certain specific early research activities. Again, they are an organization that's good in translation. But what they were looking for is the 0 to 3 TRL, as we would call technology readiness level, the early research activities that they could potentially keep a watch on. And then if something matures, something is exciting, then pick it up. So that's how the Shell IITM Center for Energy Research came in. And me being more or less putting my hand in all of these things was one of the choices for an academic chair. It's a 5-year position to look at how to strengthen this relationship and make mutual value for both partners here.
We came into the energy consortium through a different route. I think we'll talk more about the energy consortium, but let's go back a bit. And we were talking about how, from an academic point of view, academics also have, are pulled in different direction. And before that, we were talking about how the MS entrepreneurship program is coming up and how it's changed over time. So do you want to complete that thread?
Absolutely. So the logical progression of the MS entrepreneurship program, the way I see it, is now we've gotten young, I would say, curious people who are out there who want to do something different, come and pair up with faculty who are technical experts and wizards in their own way and create a startup. But it still does not complete the story because this again takes it from a 0 to 1. From a 1 to 100, we need builders. We need people who has gone through the grind of entrepreneurship, building something, failing and coming up. So what I think should happen is also a model for seasoned professionals in the industry who had gone through multiple, I would say, boom cycle, bus cycles and all, to come back and plug themselves up with this ecosystem and join any of these MS entrepreneurship teams, faculty student pair teams, as a business builder. So what we are now looking to say is that we have done tinkering, innovation, invention. Now we've started doing pre-incubation, seeding startups and all. Now we need to focus a bit more on venture building. Venture building can happen sectorally different. We work in so many different areas. I mean, you probably heard of the Institute of Eminence project, and then how IIT Madras is an Institute of Eminence, where very innovatively IITM constituted a internal call for proposals to come up with centers of excellence. And that spreads across. It's mind-boggling to say, like, more than 400 plus faculty members are involved some way or the other in creating these centers of excellence. And they are, Energy Consortium is one center of excellence, but we also have centers on lab-grown
mechanics,
sports mechanics,
lab-grown diamonds,
quantum computing,
memory
studies,
Yeah.
all kinds of topics. It's cyber security, mathematics. It's really heartening to see the level of research available. Now, what we are trying to nurture is piggyback on top of that, because there is deep tech available, experts available. Now, how can we create valuable ventures? How can we create the next 100 deep tech unicorns from IIT Madras? We have one in Unifor, and maybe Aether will probably soon become a unicorn.
Yeah.
But how do we create such deep tech unicorns which has enduring value?
So, from an innovation stack point of view, there is CFI now, there's Nirmaan, there's MS in entrepreneurship. There's, of course, a sea change in attitude that has happened through
Absolutely.
on the faculty side, on the student side. And then just outside the campus, there is incubation.
Research park and incubation, sir. Yeah.
Nice. So, you mentioned something called TRL levels. So, I've heard of them before. I know that there are 9 levels.
9 levels, yeah.
Can you just explain this concept to me, and how did this come to be?
So this TRL stands for Technology Readiness Levels. So these were introduced by NASA to validate technology before it goes into a space program. So typically TRL 0 to 3 is the science phase, and TRL 4 to 6/7 is the technology development phase, and beyond 7 to 9 is the field validation, meaning if a technology is at 9, which really means that it is validated, it's battle tested. That's the term that you used, because it was done by NASA. They were not really worried about commercialization, but they are worried about battle testing. Can it go on a space flight?
Okay.
That got adopted by a lot of engineering majors, companies like GE, Motorola, AT&T and all during that time frame, to also start looking at their own product pipeline. And they put in the same kind of gates, saying TRL 3 passed. It means I'm confident in the science. Now it's only about engineering being able to deliver the result. So you can have the greatest of science, like lithium ion battery, for example. Not many people know that it was patented and more or less proven in the late 70s and early 80s. The technology, Dr. Goodenough, who received a lot of awards for it, it was done then. But it took almost 40 years to become the mass market product it is right now.
Yeah.
So the whole technology development and commercialization follows the science, and that's where we keep looking at how can I take it forward. I may not have the manufacturing capability. I may not have the financial, I would say, incentives to commercialize something.
So, just for me to get this accurately, a TRL 4 is a prototype.
TRL 4 is a lab prototype.
A lab
Sure.
prototype.
A lab prototype where I still need to prove repeatedly that I can make a prototype and make it work. It may be at a very small scale.
Okay.
It may not be a scale at which I want to deploy.
Okay. So, then TRL 5 is a proper prototype.
TRL 5 to 6 is a field prototype. So field prototype is something still you're tinkering with it. It may not be an engineered product, but it is at a scale where you're confident that I can scale something.
Amazing. So, would it be fair to say that an academic setting like IIT, most professors would work from 0 to maybe 4?
Typically, yes. Yeah. So the reason is this. When I work from 0 to 4, most of my publications are done. Most of my patents are done. All my PhDs come through that process. I rarely get a PhD or a paper. I may get patents, but I rarely get a PhD or a publication through the 4 to 6 journey, right? Because it's, if you publish, you cannot show what is novel because I've already shown it in my science part of it.
Yeah.
So that's where academic institutions are super good at the 0 to 4 kind of journey.
Yeah. So this whole setup of CFI, Nirmaan, innovation stack, this is to move the reach of IITM from say TRL 4 to say TRL 7 or maybe even 9.
Even 9. So TRL 4 to 6 or 7, when we have multiple partners willing to commercialize it, sitting around like in the form of a consortium where I said I have 12 industry members who are observing that space and say, okay, where can I come in? And all our industrial consultancy and sponsored research where they have a series of industries that are working with our institute to say where I can pick up the technology. Or it goes all the way to 9 when we launch startups. So the startups journey essentially takes it all the way to commercial readiness. So a parallel concept is evolved where we talk about TRL. Then at some point, people said TRL is not sufficient. I need to bring in MRL, which is manufacturing readiness level. This is particularly for products which is hardware oriented and so on. And then there is also a parallel readiness level that was commercialization readiness level. So just because there is science and just because you can make it does not mean it can be commercially successful. So that's where the CRL starts coming in. So you combine all of this, you have, I would say, assessment stack for creating startups.
That's good. But I'm also thinking from a student who gets into IIT Madras, either at a BTech level or at a MS level or at a PhD level. It's interesting because maybe they are only interested in the science. Maybe they want to publish more papers. Maybe they want to be a researcher. Or maybe they want to just get enough to go work with someone else. Or they want to go the whole length. So there's opportunities in that whole journey.
Whole spectrum. Yeah.
That's amazing. Of course, all this was not there when I was a student.
I think the place itself is quite changed from a teaching institution to a learning institution. No? This transformation has been happening and it's happening worldwide, and IIT Madras, it's happening at a rapid pace. So we are no longer an instructor driven institute. This is a learning institute. So people and students particularly have an opportunity, and even faculty. So I can go plug myself into any of the centers of excellence and say, I'm here to learn. Right. So,
and if I think about it from a global level, we know that companies like Cisco and Google came out of universities or university research work. So it's a globally accepted idea that some science is happening, and then that science has evolved enough, and the university's ecosystem has allowed it to blossom into an enterprise. Maybe in India, it's a decade old, or maybe if you count.
It's not. It's now accelerating. So if you go back in IIT Madras itself, early 80s to mid 80s, there was a research group set up in the electrical engineering department called telecommunication networks. That kind of formed the seed for this whole incubation and all. But there were faculty, including our former director, Professor Bhaskar and Professor Ashok, who were trying to create enterprises out of the institute, trying to commercialize ideas. So that thought was there, but then with private capital being available, because there, the capital, we were, for a very long time, we were entirely dependent on capital from the government.
Yeah.
Now we have opened our eyes to see there is capital everywhere. It's a question of how do I tap it, and that leads to the question of what kind of impact I will make so that that capital finds me.
Sure. And in that context, it's quite amazing that they had that group at that time. And they were probably fighting a really uphill battle.
Seriously. I mean, at that point, you even had quotas on how much foreign currency you can hold. So we've come a very long way from that, but it's good to reflect and remember that we've been pioneers then, and now we are being pioneers again.
I think on this TRL level, and I mean, I'm also talking to you about Energy Consortium and Nirmaan, and sort of you're very plugged into the startup ecosystem, and of course you have your own startup. So shall we talk about that for a bit?
Sure, certainly.
So how did you get into it? And I know that your research area or your area of interest is decarbonization. Maybe we can start with you just giving us an idea of what does decarbonization mean and what is a global conversation around decarbonization.
Certainly. So I would like to convey that decarbonization is a very often used and probably misunderstood term as well, where we're not really trying to get rid of carbon. the entire world is made of carbon. If we get rid of carbon, there is no us. So there's no point in calling it as decarbonization. But what we are really referring to is minimizing emission of GHG gases, which is the greenhouse gases. As we would remember from childhood, carbon dioxide nicely creates this layer that keeps the plant warm and habitable so that we can grow our plants and biosphere and all of that exist. But what has happened is over a period of time, contributions now, the science now clearly says that this contribution has come from anthropogenic or human induced effects, that the quantum of GHG gases in our atmosphere is increasing. It's gone from some 300 odd, 350 odd ppm to beyond 400 now. And the ecosystem and the biosphere as we know it is very delicate. It has to have a certain specific threshold beyond which it goes to find a new normal. I mean, there is historical evidence Earth has had much higher levels of CO2 concentration in the atmosphere, like 900,000 ppms. It's come down to somewhere around 350, 400 ppms. And for our own well being as humans and as the current biosphere that is there, it is good to keep it at that level. Beyond which, the temperature is likely to increase because these gases trap the heat that is getting re-radiated from our Earth. That means solar heat that is getting re-radiated. So it warms the planet. As it warms, it melts the ice. As it melts, there are more and more sources of, I would say, greenhouse gases, methane being a very potent one at that. It gets released. As it gets released, you can imagine, you can understand this concept of positive feedback loops. In this case, it's positive feedback for the greenhouse gas trapping, but not so good for us because it's going to trap more. Methane is 27 times as effective as carbon dioxide in trapping that same heat. So it's going to create a problem where you create more and more warming, and you get to a point where even then when you stop all your activity, the earth is accelerating towards a new equilibrium. So that's what we kind of call as the climate change problem broadly, where this consensus was derived in some of the IPCC conference to say we need to limit to 1.5 degrees centigrade. That number really comes from this fact that if I go beyond that threshold, and sometimes it's called a tipping point, then I may find a new normal, which may not be comfortable for a lot of us living here.
In this whole argument, there's this sort of new variable on in the whole system, which is AI, because AI systems consume a lot of energy, right? So I've read that like a Google search versus a search on ChatGPT is remarkably different in terms of energy usage. So how does this put a spin on things?
It's a very good, I would say, question. And for this, we may want to look back 130 years, maybe 120 years, where there is a transition that happened from wagons driven by horses to automobile, where it really improved productivity a lot. Now, after about 130 years, we are saying transportation is one of the major contributors to greenhouse gas emissions. The usage of petroleum really accelerated after the real assembly line from Ford Model T and subsequent activities, right? Then because transportation was so fast, it accelerated globalization. There is air transport, and where we are right now can kind of be traced back to that tipping point in terms of technology evolution. What we are seeing now is something similar. AI is no doubt increasing productivity humongously. So we will likely to see a lot of use cases coming up, which will propel it even more. As it stands today, it contributes all, not just AI, but all of compute, including cloud computing, your emails and everything put together, contributes to about 2% of the global GHG emission, which is somewhere around 40 billion tons or so. It's expected that in the next 15 years, given the acceleration of AI in common usage, this number will get to about 14%. If it gets to 14%, this will immediately start becoming one of the top two sectors of GHG contribution. And since the usage is so democratized, it becomes very, very hard to control and scale it down.
And also, just it's not taking 12% from someone else. The pie is growing.
The pie is growing. It is not taking it. Right now, imagine this. To support this growth of AI, I need to create new power plants because it is power hungry. And I need base load power plants. I cannot rely on entirely renewables, and also I need to create energy supply to AI. And that's going to come more from fossil sources, though we've been adding renewables significantly. The global development hotspots still are continuing to add more and more coal power plants. And that's a challenge that needs to be addressed. And that's why, if you look at it, an interesting debate has started emerging and consensus started evolving on the use of nuclear. There was a lot of bad rap for nuclear because of all kinds of reasons. Now they're seeing it may be even a manageable problem. Now all tech majors have signed commitments with global nuclear manufacturers to put up what's called as a small modular reactor. So essentially a data center powered by one nuclear reactor running for 7-10 years. It does not emit anything. It is carbon neutral. You have to handle the nuclear waste and all of that has to be done. But now they're saying that may even be a more manageable problem than, because continued use of AI is going to demand huge amount of resources.
Scary to even think about it. Your research area is in decarbonization. So why don't we go from there, what we just discussed, to there's a gap in the middle. So you mentioned the IPCC,
Mhm.
and there are other international agreements. Can you just run us through how this is governed internationally?
So UNFCCC, the United Nations Framework Convention for Climate Change, UNFCCC is a governing body that conducts these annual COP summits. You might have heard of COP 25 to now COP 29 in Azerbaijan. Last year it was COP 28 in Dubai. So these are conference of parties. These parties are all governments and intergovernmental agencies that come together to agree on certain outputs. So it has come a long way from the concept of the whole concept of GHG emission and these kind of conventions. At one point they were worried about ozone hole. Many of us don't talk about it right now, but a while back ozone hole was a big thing. So these came up with conventions and protocols to limit emission of refrigerant CFCs particularly, and the collective action has resulted in remarkable output. The ozone was mostly closed everywhere, and no longer we use CFCs, and now we are in HFOs, and we are even phasing that out for natural refrigerants.
And you're using this as an example for global
Collective actions. Exactly. So when there is a immediate problem to be addressed, every country has to take out responsibilities, and this is a forum to commit to certain responsibilities. So the COP summits were designed for all parties to come together and discuss and debate this whole transition. It started getting a bit more serious, I think, from COP 26 in Paris, I believe, or maybe 25. But that's where countries started putting in what is called as a voluntary commitments or a nationally determined commitment. So each country, based on its own stage of development cycle, growth, economic and otherwise, said, I'm going to reduce my overall intensity of emissions for the GDP output. So these summits are in such a way that they don't do any blanket announcements. They are very nuanced, but it allows people to coordinate action. It allows people to raise capital. And now, basis that, countries then go back and declare their commitments. India has its own Panchamrit goals, where the five-fold approaches to decarbonization. It's one of which is, of course, reducing emission intensity of manufacturing from a baseline year, and then adding more renewables and so on and so forth.
The Panchamrit, one of them is reducing emissions from manufacturing sector.
Reducing overall emission intensity of the GDP. So you can imagine India's GDP is thereabouts of 4 trillion right now.
Okay.
And India's emission budget this year is about 3 billion tons or 3 gigatons. So you can kind of estimate for a 4 trillion GDP, India has emitted 3 billion tons. Now our commitment is by 2030 and 2035,
Right.
we will have a 45% reduction in that emission intensity.
Right.
Our GDP is expected to go to about 10 trillion.
Yeah.
For 10 trillion, I mean, if I even say 4 to 3, maybe about 0.75 kind of correlation. It cannot be 7.5 billion tons of
It has to be 45% less.
less than that. So that is the first commitment. And then how do I do that? I do that by adding more renewables. I do that by improving energy efficiency. And I do that by reducing my installation of coal plants and many subsequent steps there.
Can we come back to your startups that are contributing in this segment? And also, like, I think your startups are leading to sort of a venture model, right? So let's go through that route.
Absolutely. So I'll also give a little bit of background how I came into this whole ecosystem, and I think it's a bit relevant. As I did my PhD from Texas A&M in 2007, where I focused on pollution. So my PhD work was on aerosols, a science called aerosols, and technology on mitigating aerosol emissions. Particularly, I was focused on what goes to your lungs. That what is called as PM 2.5 microns, PM 10 microns, and all. That's where I worked quite a bit. Did a postdoc with Rutgers University in New Jersey on delivering drugs to lungs, essentially looking at people who have, say, asthma or other kinds of lung-based diseases. Kind of converted what I did from a mitigation perspective into a generation perspective. But then, as I don't know, fate would have it, I switched to an industry role in 2008 to GE, where I started working on coal gasification, which again took whatever I learned from an aerosol perspective, started applying it to energy. So that's my emission to energy transition.
Right.
Thereafter, I've been working with GE's Global Research Center for about 5 years, moved from coal to what a technology called waste heat recovery, where I was exposed and open to the so much of wasted opportunity in industrial manufacturing. So that's where I moved to a company called Forbes Marshall. It's a Pune-based company, which are setting up their new R&D or wanted to set up their new R&D center in IIT Madras Research Park. So I came into Research Park even when all of the other new buildings were there, just an old one white building.
Yeah.
And set up Forbes Marshall's exploratory R&D. And it's that journey that brought me to IIT, where I was trying to work with a lot of faculty to say, how do I collaboratively take technologies from your lab to the market? That's where I had a kind of a realization and also an opportunity for transition, saying that I can build a lot of technology that is relevant for the industry, while maybe if I don't focus too much on how much I get out of the small incremental work I do and focus a bit on translation. So that's how I set up my lab here in 2015.
Okay. You went from a PhD student to a postdoc to the industry to
Back to academics.
uh, in the middle you were at Research Park, and Research Park is like this bridge for IIT between IIT and hardcore research done by manufacturing. And this route was the interest area here was waste heat recovery.
Generally, waste heat recovery. So I with Forbes Marshall, I was working with the industries that consume energy, and I was
It's like
looking at everyone. So I was looking at saying, if I were to optimize, if I were to improve their efficiency, what kind of technologies are needed? There is a business as usual. You take fuel, you burn, you do something, or you consume power from the grid. I mean, broadly, any industries, you can simply look at it, right? What do? They take heating, cooling, water, air, and electricity. These 5 kind of utilities combine with the material and processing and produce products. I mean, you can kind of generalize it everywhere.
Sure. I started my career in a factory which used to make liquids,
Liquids,
liquid detergents. And so we would heat water, push
Absolutely.
water, push chemical, a lot of pneumatics, which is pressured air.
Pressured, compressed air. So that's what. So you can broadly generalize it. And then if you want to reduce your manufacturing emission intensity, you need to address those sectors. So with Forbes Marshall, I was exposed to all of these process industries, and the technologies that I was looking for is, can I make an impact right now? Is there research that is happening at the institutions which I can translate? Other ways, for example, do better combustion, better heat recovery, or better integration of processes, and so on and so forth, which kind of, it was interesting, but it's also disappointing, where research stops at a certain level and Indian industries want things at a certain different level, and there was this gap.
Yeah, again, we are talking about the TRL.
Not just the TRL, even if the TRL is mature, Indian industries particularly, or products, they want something they can take and manufacture. You give me the drawings, I will make it. There is this, of course, academics will say it's all working fine. I have proven it. Even if I progress TRL to TRL 5 or 6, it is still technology. It is not engineered. So that was a gap. And I said, let me start working on these spaces. And that's how I came into IIT and set up my lab, cheekily named as the Energy and Emissions Lab, because I was starting to work on both fronts, but more and more now focused on energy, which we started creating solutions for the emission intensity problem. Looking at how do I use energy better? How do I use more appropriate types of energy? How do I integrate more renewable energy into the system? And later, with the formation of the consortium, we started looking at how do I remove carbon dioxide emission more specifically. So that led to creation of a stack of technologies for me. Now, when I said, how do I use energy better? There are two ways to do that. Use a more appropriate type of energy when you need only like 70-degree hot water. Don't burn coal or diesel, which is a much powerful fuel.
No.
Use something more simpler so that I can build solutions addressing that particular market. So we created a technology called heat pump, which is super common. Everybody knows it.
Yeah.
But it's not used it in the sense I was trying to do. So there was some innovation that was required. Some innovation in an academic stance, it's an incremental innovation, so people may not be super excited about it. But from an industry standpoint, it was a game changer. Like for example, in 2016, when I was starting to deploy some solutions in the market, people are like, this is cutting down my energy bill by 50%, 60%. Why did I not do it? So that led to one of my first ventures, which I was in the beginning, I wasn't sure how to commercialize it. So I was partnering with somebody to say, he has a startup, so I will build the solutions. I will be part of your advisory board and so on. Let's deploy it for a while. And then last year we said it needs a more focused effort. So we created one of the startups called Trigen DC,
Trigen DC.
which is focused on industrial decarbonization, primarily heating. But heat pumps, as you know, also supports cooling. So we said Trigen stands for heating and cooling along with storage. So essentially you entirely focus on decarbonizing that two space.
And DC being for decarbonization.
Decarbonization. So that's primarily what it is. In the process, we also realized steam as a working fluid. So you've been in a manufacturing industry, so you know steam is a very common working fluid.
Yeah.
Everybody uses a boiler and uses steam. What is not really appreciated is oftentimes boiler runs at some 10 bar, 15 bar or 17 bar, 25 bar standard operating pressures, but the usage is much lower.
Yeah.
The thermodynamics dictates that if you need 120, drop it down to 1 bar. So they use a throttle valve. It's very much like a tap that you use in your home. In that process, you are destroying the potential of that steam. So we said, there is engines, there is turbines that is available, but why are people not using it? So there was a big gap which said, the reason they are not using it is steam as it comes out from these boilers have a lot of moisture in it. It's called wetness of steam, which when you put it through a turbine acts like stones. It's almost like water jet cutting because the velocities are so high, it will eat the blade. So there is a maintenance issue. People generally said, okay, this is a technology conceptually is good, but doesn't work because of these issues. And the other problem in peculiar to India is all our manufacturing is very flexible. There is high load, there is low load, and all kind of variations are there. And turbines as a technology exists do not like those kind of variations. So because of which the potential was untapped. So we created a research project where I got lucky to get my first funding from Department of Science and Technology to mature that. And over the last 6 years, we built a technology stack which addresses this problem and launched a company called Vankel Energy Systems, which is primarily looking to pressure to power recovery in process plants. We got a couple of patents in the process. We were the top 8 teams among the finalists in the MIT's Clean Energy Prize among 160 plus teams. We presented in the semifinals in London and the finals in Boston at MIT. It's a phenomenal technology. It's simple. People say it is steam. What is there to research in steam? But so much more to do. And we were able to, I got a couple of PhDs out of it from an academic perspective and a couple of publications, but more importantly, a startup which is dependent and corely built on IP, which is developed at IIT Madras.
Can you give me a sense? It sounds lovely, but we started our conversation with international commitments and so on. In the manufacturing sector, suppose I recover energy from steam, suppose I recover energy from pressure wastage or whatever, how much does it contribute to our national goal?
Significantly. So if I can simply tell you the potential from steam, as in India alone, as we have installed the number of boilers and so on, it's upwards of 20 gigawatt of untapped potential. And this is something that you are wasting every day. It's like a leaky water, leaky tap. Now, all I need is to implement such solutions to recover. And this is almost free power, which you are currently not utilizing. This is equivalent of adding 60, 70 gigawatts of solar because of the plant load efficiency and factor. So our annual solar installation goal was about 50 gigawatts for the next 5 years. So this is like 1 year's worth of solar and it's running 24/7. And imagine all the new plants to be built. And this is just India. So it's a very large opportunity in terms of the millions of tons of CO2 that you can avoid. As of now, if I only tap the installed base in India, I can go close to about 160, 200 million tons of CO2 emitted. So that is really about, if you look at it, about 5 to 10% of the current India's emission just for one product.
That is quite intense.
And add to that, you substitute the other kinds of heating fuels. As I said, you go to a heat pump and so on, and potentially powered through renewable power, then you are adding another 100 million tons. So these are like two products that takes it. And this addresses the first point, saying, how do I reduce the intensity of emissions? Because
I remember in our preparation work, you spoke about 4 points. So the first point was, and you mentioned it's a pyramid. So do you want to take us through the pyramid structure?
absolutely, I mean, conceptually, right? Say, for example, if you are trying to increase your wealth, you first try to cut down your losses. You use money more appropriately for things that you need to use that derives value. That you try to cut down unnecessary wastage. You try to put in more sustainable sources in terms of renewing and so on. And then you try to say whatever mistakes you have done in the past, you try to undo that mistakes. Same thing applies in energy. If you look at energy as a currency, you have to start using energy in the most appropriate form. An example I gave is, if you need only hot water at 70 degrees centigrade, don't burn diesel at 900. Diesel is a very powerful fuel. You assume that you'll continue to use diesel, but don't do that. Even biomass, which is considered renewable, but then it still burns at 700, 800 degrees C. You don't need it for 70 degrees centigrade. So you cut that down, and then you also use it more efficiently. First of all, improve the efficiency of utilization. You have a heat exchanger, or you have any kind of process plant. Make sure that you utilize only that you need. Previously, I think we were capital starved. So we almost always optimized on the ability to do future work without having to install new capital. So energy wasn't that big a deal.
Yeah.
Now we are more energy starved. So we need to be energy efficient. Previously, we had capital efficient. Now, once you do these two, then the third step in that pyramid is integrating more renewables. Of course, we know renewables are intermittent, so we need ability to manage interruptions. Interruptions can be managed by storage. We know electrochemical or batteries as a storage system, but then there are other ways of storage, including thermal energy storage, including storage as heat and pressure and so on. It could also be by way of management, particularly the underlooked aspect of renewable integration is demand side management. There are lots of loads that are schedulable, but that requires a whole digital infrastructure to control and manage and so on. But that's an evolving area. That's not.
I mean, the most common example that we all know for sure is that if EV workloads were to be scheduled at night, then it would skip increasing the peak load in the morning.
Absolutely, absolutely. You could do that, and then you can also make it dynamic. Like a lot of time we take EVs, cars and so on, it's parked.
Yeah.
90% of the time personal vehicles are parked. So you can figure out a way to use those as an arbitrage opportunity. I mean, these are all 50 kilowatt hour, 40 kilowatt hour batteries that is waiting to be utilized. So if you figure out a mechanism to tap onto them, that becomes a large opportunity, and it also incentivizes. Right now, the EV sector is struggling primarily because you're only looking at EV as decarbonizing transport, and they contribute very little. But if you start looking at them as a grid arbitrage opportunity, becomes much, much bigger. Because as you already know, you walk through this campus, you can see 90% of the vehicles are just parked. Imagine all of them are EVs. So you use their batteries as dispatch control or frequency control or even arbitrage. So here you need to think of an alternative mechanism to say, I don't own the battery. I own the platform. Battery is a common resource. So there are a lot more, I would say, innovation need to come in, but then there's whole change in mindset. We are now, ownership.
So it sounds very futuristic, but reducing wasted heat at manufacturing facilities to have a 5%, 10% impact on our national global emission goal. That sounds like within 5-10 years it can be done.
It's not 5-10 years also. It's a here and now opportunity. In fact, to get to our 35% emission intensity, our target is 2030. So it's a here and now opportunity, and these are happening right now. For example, as two of my companies are working in these domains, and there are multiple people who have started working on it. Heat pumps are a global phenomenon right now. If you go to Europe, you have a 18-month waiting period to get a heat pump for your home. There, people are more worried about home heating.
Yeah.
Ukraine war exposed it even more.
Sure.
And US had rolled out extensive, I would say, credits through the Inflation Reduction Act and so on for heat pumps and upgrades on that. US DOE is pumping millions of dollars on technology development for heat pump, particularly focused on industrial upgrades and so on. So it's a activity that's happening now.
Professor, you speak of startups so fluidly and so effortlessly. I have to ask you this. How many startups are you involved in? Like personally, not as a mentor.
So personally, I'm actively involved in at least 4 startups.
Okay.
Then I would say my shareholding is there at least another two startups. So it's about 6 of them.
So the first one is Trigen 3D, which works at industrial waste heat management. The second one works in
Pressure recovery,
the
Wankel energy systems,
which has a few patents, and then on.
The third one is, as I was talking about, there has to be a management of all of these energy systems together. So the third startup is called Energy ETA. ETA is our thermodynamic term for efficiency. So really, we are trying to build an energy efficiency operating system.
Right.
Primarily say, if all of these devices need to come on, I need a smart management platform, which is not only dependent on data, because if you are only dependent on data and you plug in AI models and all, it's going to become its own nightmare. So we are really looking to leverage the knowledge that's available. That's what we call as the physics-informed machine learning. Physics drives almost everything. Machine learning is a cherry on the cake, which improves predictability a little bit more. Where there are gray areas in physics where I have a divergence, so machine learning helps to bring the divergence narrow. So make it into an energy efficient platform for energy efficiency management. That is the third one. In doing all of this, what I also realized is, as academics, I can keep coming up with more and more and more, and I would like to translate all of them. But I cannot meaningfully be part of all of them. And I would like to go back to the lab and develop more. So there is a need for a venture builder of sorts who has the experience in taking solutions by creating startups to the market and scaling them. So the fourth startup that I'm involved with is a company called Indus DC. Indus is the Indus Valley civilization that we have created for the world, and DC again is decarbonization. The idea there is to take very promising IP and technology out of labs from India, but globally as well, and to commercialize it. When I say commercialize it, get it to a product market fit in about 18 to 36 months and scale them. And this is a challenge that needs to be addressed globally. When you go talk to any university in, say, Europe or wherever, this is a gap that academics, faculty, postdocs, PhDs are good at creating the technology. But then even when you give them more venture funding, the success is not guaranteed. They may use the funding back to more research. So, I mean, we acknowledge the problem. So I think you need venture builders. And this is a company that we started with an IITM alum from 92 who came back after exiting he is a PhD. He came back after exiting his first startup and said, I want to do something more. I said, let's build a studio that will build more startup. And we need to have focus. We can't do very much because in each of this venture builder, along with the inventor, will go in as a co-founder and create a startup. So we potentially could do maybe 3 to 5 startups every 3 years.
It's very interesting when you speak about these things. In a common perception, because some of these startups have become very big, and I want to bring in 2 points. One is that when people think of startups, they, at least in India, they think of e-commerce, they think of D2C, they think of a consumer startup that's not really innovating on the, maybe it's some innovation on the product side, but more innovation on the market and the business side. And secondly, when people think of engineering, increasingly people think of AI, machine learning. Like if I go out and say I'm an engineer, then maybe 15 years back or 30 years back, people would think I'm building robots or bridges. I don't know. But now everybody thinks engineer equal to coder. So do you have these perception issues? One with respect to what is the common understanding of a startup? And you are talking of all the startups you spoke of are in deep tech, industrial technology, climate technology, and so on, right?
Yes, it's super hard. That's why I failed before. My experiences so far are that we can take something to, I would say, even a field validation stage. Even beyond that, there's a lot of engineering that goes on. Once you deploy a machinery in the field, it requires constant, I would say, upgrades, engineering support. When you look at, for example, the air conditioner that you have in your home, you want 7-year reliability.
Yeah.
And you want, if something goes wrong, you want within
Someone to come
24
now
hours,
and fix it.
now and fix it. Now, as a industrial technology startup, that limits my ability to scale so much. Because if I deploy 5 machines in the field and I have 5 engineers that I'm working with, if something goes wrong, I can't do the next job. So this requires, I think, very patient capital and not the hockey stick scaling. So that's the reason why you find it so hard to create these kind of deep tech startups as of now. Some of them have scaled. We have examples, very good examples in our research park. And that is one of the unique features because they work on industrial technology. But they are also they're also working on a bit of an asset light technology stack. There's a lot of IP, there is a lot of human resource cost. But most of it, like sensors or whatever that may be, is asset light. Now, what I'm talking about is also asset heavy.
Yeah.
So that's where we want to look at
It's not just hard tech, it's heavy tech.
heavy tech. It's industrial, as you said, industrial tech, capital goods tech. And a single product for me is 1 crore to deploy. So I may be deploying 2 to 3 units in a year, but that's like 3 crores. So you can imagine the kind of engineering and everything that goes in. So the question that you come back is the perception, right? 15 years back, they would have asked you if you are in IT. I think 15 years before that, probably you were in the civil, mechanical, or whatever it is. I know this example because when I was doing my postdoc, I was roaming around somewhere in New Jersey or in New York, and I said, I'm from India, and somebody said, oh, you're from India, you should be in IT. So there, that was the perception. And now I think, as you said, you might be a AI guy, or probably if you say you are in engineering, they might think you already have a startup. That's probably at least in Bangalore.
At least in Bangalore, yeah.
At least in Bangalore. Or if not, you at least have a side hustle startup. You may be working for some company
Or you're helping a startup.
or helping a startup. So, but I think if you say you are from IIT, there is also an expectation that maybe you're building something deeper. Industries particularly are a lot more open now to be experimental with tech that's coming from IIT. So I go to a TVS or I go to a Tata Motors, or 10 years ago, they would not even touch it.
Right.
They're like, this is headache. This is a headache for my maintenance. This is a headache for everything. Even though you give it to me free of cost, I will not take it. Now there is a lot of openness to experimenting. Now I have people coming and telling me, why don't you deploy this in my plant? You can send your students there. You can send your staff there. We will work with you to provide data. You can de-risk your technology in my lab, in my plant. So that openness has started to come in because they are also seeing, for them, growth and value comes in these kind of interventions. They can always wait for technology to mature somewhere else in the world and come here, or they can scout for opportunities locally and start supporting. It is also driven by second generation entrepreneurs. The parents' generation were more risk averse. Now the second generation industrial tech particularly, it's all what used to be family owned businesses now scaled fairly reasonably. Second generation entrepreneurs have been exposed to this kind of tech outside. They've been to US for their studies and so on. So they know that this is how it matures.
That's very interesting. Do you think that when you go to an industry today, I mean, I've heard this term used by other entrepreneurs in the IIT hardware ecosystem. The term they use is liability of origin, where they look down on you because of where you're from, in the sense that you guys don't know how to build something. Do you think that has changed a lot? I mean, I guess you hinted at it, but I just wanted to.
So I would say it hasn't changed en masse, but it has changed in many organizations. For example, I can now go to a company called ZF, which is a German company, which is traditionally very conservative. And I have deployed my one of the most experimental prototype in their plant. It's my first prototype I built and I deployed it. And similarly, I went to Lucas TVS, the TVS group, which is very well known for cost efficiency.
Correct. But very conservative.
Very conservative decision making. I've deployed my first ever 95-degree heat pump I built with their plant. So they are also looking at saying, how can I be innovative?
Right.
It's also coming outside in, because now these companies are global companies.
Yeah.
And the reason why ZF came to us and started working with us, the reason why Strides Pharma is working with us, the reason why this guy Lucas TVS came to us is because they also kind of want to tell that they are not just job shops, they are not just contract manufacturers, they are also innovators.
Right. It's an interesting position there. They are also changing.
They're also changing, and that's how we position it. We say when you say this is a tech globally available, now I'm making it in India, that's a different sell. You say this is global best tech, we're building it out of India, and you are going to be the pioneer.
Yeah.
If you want to be the pioneer, you test it. It's going to be failing. It's going to be having all of the challenge. But once we succeed, you would have been the first person to have deployed it.
Sure.
That's a different.
Maybe there's a little bit of sort of fear of missing out, because if this is a technology that will work,
Correct.
I don't want my competitor to get it first.
That is one. But then these guys are also presenting in global forums, and they say that, see,
Okay.
when they go to a Europe and say, I have deployed this kind of a technology, and in a forum which is filled with peers, this becomes kind of a chip on the shoulder, a talking point. Oh, you've deployed it even in Europe, it's still in the lab phase, and how come you move so fast? Because Europe, of course, moves very slow because of all regulatory and all of things, but we move a bit faster.
That's damn interesting. So we spoke about Nirmaan, we spoke about your love for startups. Yeah, and Nirmaan, the innovation ecosystem has moved from CFI Nirmaan to now full stack. We also spoke about your own personal research areas in decarbonization, how your journey has been to come to IIT Madras. The academic work you do combined with the entrepreneurial work you do, that's a huge amount of workload. So I'm wondering, how do you find the time or the energy for so much?
I mean, you probably should be asking people who try to reach me and get frustrated. I think you probably have been on the receiving side of some of those activities. I can understand. So I tried to explain, but now I said, okay, I'm just. But then I think it is also about building teams. Finally, it's all about building teams. So you build a great team, and they are happy that whatever you translated works. So I think my personal journey in terms of learning has been about this aspect. So where you could be so proud that you can do it versus you can be so proud that the person whom you train can do it. I think that's the liberating aspect of it. Now, if I can say that I don't focus much on my heat pumps, I have a team which can build it. I don't have to go there to de-risk it. I don't have to put myself in front of a customer to sell it. Somebody else can sell it. I don't have to sell it on my credentials, but my team can sell it on their own, and I have really stepped out. That's what's, I mean, even in my audit work that we do, we have set up these nationwide centers of energy audit, which is exceptionally doing good work. But in the beginning, I used to go for the audits along with these guys. I used to be the person who used to convince others to come with IITM. Now the team has its own brand. I need not go anywhere.
So yeah, I think you mentioned earlier at some point that you would see yourself more as a 0 to 1 person to get something off the ground and moving.
Yeah.
Do you, we use this in our marketing when we talk to students who are coming into IIT Madras, that IIT Madras is the best place to build. Do you agree with that statement?
I think, as I've seen quite a few institutions and across far ahead of many other places to build, the tolerance and the celebration of risk here is far higher than anywhere else. It permeates across the institute, right from the director to everybody who's involved. So I think that's one of the biggest differentiating factor.
That's interesting. We have gone from avoidance of risk to tolerance of risk to you are saying celebration of risk.
Celebration of risk. Which other institute would be getting into this journey of setting up an international campus in a place like Africa in 6 months? Imagine it's a governmental, multi-governmental thing, and You completely unknown. Maybe if you're setting up in Dubai or Abu Dhabi and all, it's a mature ecosystem. There's a lot of money. You can call somebody and they can donate and all. It's a established system.
There are also lots of Indians.
Lots of Indians go to East Africa. And in East Africa, you go to a tiny island called Zanzibar, and you set up a fully functional institute, and it is now admitting its third cohort. And you are managing to pull it through, and now you've secured scholarship for all students.
It's very intense.
And it's very intense, and without the mindset of celebrating risk, it cannot happen. I mean, there will always be a devil's advocate who will say, let me tell you how it will not work. And I can tell my own devil's advocate people who said, when we started setting up the consortium here, I had enough people say, let me tell you why consortium will not work. I said, that's fine.
But
we have to try. And we have excellent alumni like yourself who said, you're going to try this, I'm going to seed fund it. Don't know what will happen. Here I'll give you.
I mean, I was not the seed funder.
You are not the seed funder, of course. But I said, alumni who like to contribute and say that, see, I will seed fund the effort.
Yeah.
It's one of the earliest batches of IIT Madras from the early 1960s who said, I'll give you $200,000. You do what you want to set up an office and figure out how it works. So that attitude saying that, see, there are people who believes in this risk and let's take it. I mean, worst is I've tried. The best outcome is something to show.
Professor, in this whole best place to build thing, we've discussed institutions like CFI and Nirmaan, which help students, faculty to come together, experiment. There's an entrepreneurship. There are, of course, lots of labs, industrial collaboration. There's a research park. There's an incubation cell. In addition, you have mentioned some patents along the way we had this conversation. What is the process in IITM for patent discovery, filing, licensing, and so on?
Yeah, it starts with an intent to patent. So you have an idea that you want to protect. So you file for an invention disclosure form, and then we have a very functional IP cell, which is housed under in our ICSR, which looks at patentability and does the search of innovation and all, comes back with what could be done to protect if we have novelty in it. And once that is done, then it goes to the next phase where you do the filing. The filing happens at two levels. One, if you say, I'm only going to protect this in India, you do an India filing. But if you want to protect it globally, you do something called as a PCT, which is a patent cooperation treaty, where you file in multiple geographies. So here, the institute pays for India filing all of the cost of filing. And for global filing, it will cover maybe about 70-75% of the cost. The 25% is borne by the inventor. So that if we go for international filing, if there is an interest to protect it elsewhere, particularly we are focused on commercialization and so on. Once the patent process is done, then we have a technology transfer office where they kind of bunch together a certain thematic set of patents. Like, let's say you want to commercialize something in 6G. Right now we have a fantastic 6G test bed. And then we have a lot of innovation coming on how to optimize, how to reduce energy requirements and all. So then if you want to commercially exploit them, so they create a technology stack that they offer, talking to multiple entities that are interested. Similarly, we are trying to create a decarbonization stack. So that is when you want to license the patent to a larger commercial entity or somebody who will exploit it. There is also a parallel path where, like startups like mine, I'm going to use my patent to commercialize it. So IITM has a fantastic support ecosystem where they say you pay minimally for just the filing charges. I don't ask you to give me the commercial value of a patent or whatever that may be, because it is unknown. You are exploiting. I don't know how much it will be valuable for you, and you are raising money or whatever. And if you're going to charge me everything, then I have no way to recover that fund. So it's a burden on the startup. So they do a process where they work on a royalty basis. And the royalties are fairly reasonable. Royalty is based on the revenue and based on the profits that you make over a period of, say, 5 years. And in the period, IITM is very open to giving it to you exclusively as well. So you have that moat that you have created and you try to exploit it. And if at the end of 3 to 5 years, you are not able to commercially exploit it, IITM can claw back the patent and then open it up for other people. So that way, it's a super enabling ecosystem, which, as you already know, patents are just, I would say, a starting point. You need to build so much more, but it kind of gives you that credibility saying,
Sure.
I have a license to commercialize.
Sure.
Yeah.
A patent is not sufficient to build a business, but it's a good.
It's a good to have. It's a good to have primarily when you are trying to raise some funding. Yeah, it becomes a way of saying that, say, I have a technology differentiator. Yeah, because oftentimes market is not able to understand how different you are, particularly the investment market. So this becomes kind of a differentiator, saying that, see, I have these set of patents.
Yeah.
So that kind of puts you up in terms of your valuation. Early stage startup, there is no way to figure out valuation. So these are metrics that happen.
Okay, this was great. Thank you so much for coming, and really grateful for the amazing work that you've done, especially around CFI Nirmaan, which I personally care a lot about, and maybe some of our audience would. I do hope that maybe in a year or two we get to speak again, and all the things that you're talking about has moved forward.
Certainly. Thank you very much. Thanks for having me here.
Here.